Hello everyone, Siddharth this side, and in this video we will be solving another question on lead code, which is binary tree right side view. So this question is quite similar as the previous question that we had solved yesterday, which is left view of binary tree. So I would suggest that go and solve that question first, because uh, if you will solve that question, then you have to just uh, you don't have to change anything. Just you just have to swap something and you can able to solve this question as well. So let's see how we can use that approach. So in this question as well, so suppose this is a tree, 1 2 3 4, and take here 5 and take here 6. Now what we had done earlier is that first we have visited the left child because we want to add the left child first. But here what we have to do, we have to print the right side view, store the elements of the right side view. So what we do, instead of visiting the left node first, we will be visiting right node first. So in this manner we will able to store only the right elements, and we will be using the same approach that we had used earlier. uh, we will be initializing depth and array list size, and this is depth 0, and after adding 1 to his array, to our array list, our depth will become al dot size will become 1, and depth will also increase in the next recursive call. So this they will match always, and here also. So now we will add 1 3 6 into our array list, and for these two elements, so after visiting this, we will be calling for its left. It will return as it is null. Same for here. It will return here. Now it will call to its left child. Now this is also null, so we will be returning from here as well. It will return, and now it is this parent is waiting for its right call to finish. Now it will call for its left child. Now same here. Now it will call for its right child, as we are calling right child first. Now again, now if you will try to check level here, for this is level 0. Now after that this will become level 1, but our al size already become 3 here. So if we will check al size here, it will not match 2 because 1 does not equal to 3. So we will not be adding any of these elements. We will be adding only the right view. So in this manner we can solve this question. So let's see. So let's make a function as well. So public, this will return void, as we will be just operating our array list, and its name should be, let's see, right, and we will be passing a tree node root, and apart from that we will be passing depth as well, and after that we will be passing uh, array list. So array list, sorry, here we have to return list, so define list integer al is equals to, okay. Now let's handle the base case. So if root is equals to null, in that case we just have to return from there. And next base case is if a depth will become equals to the size of the array list, so al dot size. And in this case what we have to do, we have to just add the root dot value. So this will store that root into an array list. Now let's call for its right child first, then left child. So right root dot right, and let's pass depth as well. So depth plus 1, and array list same. So now let's call for its left child. So root dot left, depth plus 1, and array list. Now after doing this, we just have to, we don't have to return anything. So this function is already completed. Now what we have to do, let's define it, let's handle the case when root is null. So if root is equals to null, in that case we just have to return new list, list of integer. So okay, Now let's make an list as well. So list teaser, let's name as al is equals to new list integer. Okay, after doing this, what we have to do, we just have to call a function which will going to be update our array list. So right, we will be passing a root node and then passing depth as 0 for the first iteration, for the first recursive call, and we will be passing a array list. Now in the end, we will be returning this al. Now let's try to run this code. Let's see if there is some problem. Okay, okay, now let's try to run this. Okay, so let's submit this as well. So all the test cases have been processed. So thank you. See you in the next video. Bye.